Ramyea, a PhD scholar of Konga Engineering College, Tamil Nadu, India. My research topic is on wideband polymer antennas for future wireless communications. Antenna is a heart of wireless communication systems. So, in this context, I have replaced FR4 based rigid antennas with polymer based antennas, which can be suitable for flexible applications. So, the first one is polyethylene based antenna, which is resonated from 5 to 8 gigahertz with a dielectric constant of 2.25 and operating point at 7.3 gigahertz. And again, the structure is shown here with 4 microslots, which is also fabricated and tested for real-time measurements. And again, activity is greater than 6 we have obtained. And this polyethylene sheet is actually used to do fabricate the antenna. Um, uh, Next to this, my next work is on dual port antenna. Uh, it's implemented in a PTFE based substrate. This PTFE is called tetrafluoroethylene. It's the dielectric constant of 2. Again, dual port. The first port covers ultra wideband from 3.1 to 10.6 gigahertz, and the second one is narrowband antennas, which covers three different frequencies: 4.8, 5.6, and 8 gigahertz. It is suitable for narrowband communications. Parallel sensing can be done done through the sensing antennas. Mainly, it is focused to operate in cooperative radio-based flexible applications. Like the same antenna is fabricated and the frequency reconfigurability is introduced by means of circular ring rotation through a mechanical rotation. The rotation is explained via this flow chart. Flow chart gives an overall view of how this rotation is being done to enable frequency reconfigurability. Again, some of the applications which can be used in cognitive radio using flexible materials or fire services, education services, transportations, biomedical services, and etc. And the next work is preparing composite substrate to replace FR4s. Like polyvinyl alcohol and graphite is combined in a powder form to the water, and it is continuously stirring using magnetic stirrer, and it is cooled down to a normal temperature to form a composite gel structure. After obtaining the composite gel structure, after leaving it for a few hours, we will get a thin film-like structure. The thin film is can again taken and connected to a LCR meter to measure the capacitance value. So the right side is nothing but the schematic of the simple elliptical antenna, and the same is measured using DME and also chamber. Again, the lower one is nothing but this rigid antennas that is just a show to compare the flexibility of the proposed antenna. Again, this proposed antenna is being can be applied to most all flexible applications like wireless speakers, smart glasses, smartwatch, smart clothes, and smart shoes, etc. So my idea is mainly to use a flexible antennas for flexible applications, flexible wireless applications. Thank you.